All right, let's talk object detection. So in this video, we're only going to talk about object detection as a way to do classification. Um, Traditional object detection also gives you like boxes and bounds within your images of like where the actual object is. But as we mentioned in the lecture, one of the nice things about object detection is it's not a single image, a single class label. Object detection can have multiple objects in it, therefore it can provide multiple classes per image. So in the case of everything we've been looking at, which is like dogs and cats, you know that if there's an image with both a cat and a dog, in a traditional classifier, it has to pick one of those. So it's either a cat or a dog, and that's probably a low confidence score when it does that. With object detection, which we'll look at now, we can actually look for both cats and dogs in that image and then turn that into sort of a multimodal classifier. So that's what we're going to do here. So we'll just go ahead and get started. This does not require a GPU. YOLO V8, which is the version we're going to use. It's called YOLO because it's you only look once. I don't know what, I mean, it's because it's fast basically, but it generates object detection. So we'll go ahead and run this now. So let's get started by connecting to our drive. And then we'll install the library required for YOLO, which is this company Ultralytics. It's actually like a bunch of people that use the term YOLO for their models. It's kind of complicated. But anyway, we're going to use the latest version, YOLO V8, which is run by this company called Ultralytics. Next, we will skip this step because we don't actually need to convert our video to frames. If you have not done this yet and you want to apply this for object detection, or maybe you want to use a different data set or different video clips, you'll need to run this in order to produce your frames. But this is run on frames. YOLO can actually run on video, but it's kind of slow because it runs through literally every frame. And I don't think there's a way to fix that or change that. So if you try to run it over long videos, it literally produces bounding boxes and object detection for every single frame, which, as we've talked about, is kind of overkill. So we're just going to run it on frames. So in here, in Drive, My Drive, Algo Film, Frames, we've got a couple of frames we can play with here. Let's go ahead and load in our helper function. Actually, this just loads the model. There are a bunch of different models for YOLO V8. If you go to the Ultralytics website, you can see. I'm grabbing 8X, which is the largest model, which therefore means it should be the best performance, but it's also the largest, so it's the slowest. YOLO also works on mobile devices and other things, so if you wanted to do something more mobile friendly, you could do that outside the scope of this class, but I'm loading in 8X. Next, we'll pull in some helper functions. And let's go ahead and grab a frame here. So let's grab something from our Milo and Otis piece. And let's just grab one. Don't know what this is, so we'll find out. So we're going to put in the path, and what will happen is we'll see the image as well as what our objects are. And actually what I want to do real quick is I'm going to uncomment this print line, and this will show us all of the boxes for a single frame. And now I'll run this. And here you go. This gave me a sheep. Now, if I were to dig into this more, I would actually see there's also the bounds of the sheep. For this, I don't really care. We just want the class out of it. I want to see if I can find one. I would think I would have taken better notes here, where we get multiple animals. Because that's really the best result of these models. Here we go. Well, maybe there isn't a crab object within the Coco dataset, but we do get our cat. Let's see if I can find something else here. Nothing. Although it does know that's a bird, which I guess is good. I wouldn't have even seen a bird there, but it does find a bird. Let's try a couple more and just see if we can find one that gives us multiple results. Here you go. This is good. This gives you a vase and a bird. Now it missed the dog, But this is what's really helpful about these particular models, is that you can get multiple classes from a single image. And that's what's different from it from a traditional classifier model. I'm going to do one more here. Let's see if I can grab something else. There we go. Perfect. This is exactly what I wanted to see. On the last one, it took me long enough, but I got there. So in this case of this film, there's a lot of scenes with a dog and a cat together. And unfortunately, with a traditional classifier, you cannot get a class of a dog and a cat. I guess you could maybe train it to be like single dog, single cat, dog and cat. But in this case, we would have to do a custom training. In this case, this actually gives us both of what we want. So dog and cat. So let's go ahead and run this on a folder of images. And all it does for a folder in this case is we process every frame individually, and then we combine them all to get all of the unique objects in the scene. So let's actually grab this path. And this should point to a folder, not a single image. And you'll see here in this particular video, this is a great example of a video where something might be changing a lot. I would need to go in and grab the video to actually find out. But in this case, it looks like you're seeing dog, cat, dog, cat, dog, cat, dog, cat. And then at some point, you're starting to see sheep, which is a great example of sort of like there's something going on in this clip where something might be changing. And it's, finding a dog, cat, and a sheep in this clip. And that's exactly what we want, right? We want to know what is in this clip, not just what is in a single frame of this clip. So this ends up being a really great example. Now that we've sort of figured out this works and we're seeing our results here, I'm going to do one thing and just sort of turn off this print statement. This print statement can get kind of long as you process every single frame, so I just turn that off. But it's there if you want to turn it on in order to see what each frame represents. So each frame is finding these dogs and cats and then sheep. Okay, so now we can run this on our entire folder. So we could go up a level here. And we could copy this and stick this in our frames path. And then let's make sure our JSON path is also correct. And if we want to filter by whatever is the same as this. So we're going to, anything with the folder inside of here with Milo is going to be the best answer. I already ran this. So I'm actually, if I run this again, it'll just tell me that it's already run. Yeah, just we'll run everything and just say like, hey, we're done. Although it does, it looked like it grabbed, there's a couple left here. So this is great. We'll see what happens here. Now it looks like sometimes it doesn't find anything at all. And that could be because it's either a credit sequence. It could be that whatever is in the Coco data set. So as you mentioned, this is trained on Coco. That's not right. Coco dataset classes. I was just looking this up. And here we can open this. And here are the classes for Coco. I don't know exactly which one this is trained on, but they look pretty similar. So we've got person, bicycle, car, motorcycle, airplane, bus, train, sheep, cow, elephant, all the way down to hairbrush. So it looks like there are 91 total classes. But what's nice about this class is it does give you person. So if you are looking for a only person-based model, or you want to go through your film clips and only pull out the clips that have people in it, then this is the way to do that. So that's kind of helpful there. Let's see. Okay, we're finding cat, dog, cat, dog, cat, dog, dog, sheep. So we are finding some things, and you'll see this is an interesting one, bear, cat, and dog. So in this case, what we're able to then do is actually grab all of these pieces together. And what I find really helpful here is, again, let's say you want just the clips with both cats and dogs together. You can't get that from a traditional classifier. It just doesn't work that way. With this, what we'll look at in the next cell, actually, I'll just stop this now. And I'll just run this last cell just to save whatever I had in here. Let me see. It's not there. So this will just save the data that it recently created. And now what I want to do is I want to go in and grab from my classifications just the labels that have a cat and a dog. I could also make this a bear and a dog. So the difference is you can't really edit this over here. You have to edit this here. So I'll make a little note here with text. And this is greedy, or it's not greedy, it's inclusive. So this will only pull videos that have both a bear and a dog in the video. It will not pull all the bear clips and all the dog clips. That would be would require a different setup here. But if I run this, I should at least get that one video we just saw. So let's see. So there's actually 15 clips in this that have both bears and dogs in them. That's kind of fun. So again, what I was doing before was I was getting a cat and a dog. And this gives me 32 clips. So this is sort of like the buddy cop movie. This is where all the clips with the dog and the cat together are. If you never watched the movie, there's a story where they like separate and they get back together. So it's like a lot of the film actually doesn't have them together. Only the beginning and end does. So this is kind of helpful in what I would expect. At that point, we can now turn that into a video. I've already gone ahead and done that, and I will upload it to Vimeo so you have an example of this. But I think object detection as in this technique is actually really, really powerful. And it gives you that ability to find multiple classes together, which is unique and not always the easiest thing. I should also mention if you just want just the cat videos again, like we've been doing, you can grab just the cat videos. And the nice thing about this is if the dog is more predominant in that video, but there's still a cat in it, it will grab that as well. So that may be good or that may be bad depending on what you want to do. If you want just cats and just purely cats, you're more likely to get that from a traditional classifier. Or you would actually need to run some sort of like multi-stage if-else statement in this cell to actually just exclude any clips that have dogs and cats, or sorry, that have just cats and no dogs and maybe nothing else. So you'd need to sort of figure out how to do that. But yeah, that's it for object detection. I think this is really cool. I would definitely recommend playing with it because it's probably more flexible than other classifiers and it gives you a little bit more. It's actually quite fast too. I think it took like 30 minutes to run an entire set of like a feature-length film, and that's, on a CPU, so it's very cheap too. All right, so that's object detection. I think at this point we're going to move into generating captions, which are much more flexible in terms of like what they can describe, but are not as easy to actually collect. So we'll jump into using Blip2 next. So I'll see you there.